Hello everybody, it's Mr. Williams here again, and I'm here to do another online maths lesson with you today. And in this session, we are going to use our place value knowledge to find some mysterious missing numbers. As always, we need our friends here to help us, so let's get straight on and warm up our maths brains. Okay, it's time to play your cards right. Okay, for this game we have got a pack of cards from 0 to 100, which we are going to shuffle up, and then we are going to choose just 6 cards from the pack. So here are our 6 cards, and I'm just going to reveal the very first card, which is a 20. Now the first thing we're going to do is to see if we can work out where on our number line from 0 to 100 that 20 would go. Can you point to where you think it would be? Okay, so each division on that number line is 10. So number 20 would go just here on our number line. Okay, so remember we've got all the cards there from 0 to 100. Now, do you think the next number along is going to be higher or lower than 20? Shout out what you think. Okay, let's reveal the next card. The next card is 62. Now, can you point on our number line to where you think 62 would be? Okay, so remember our divisions are in 10, so if I count along to where I think 60 is, then 62 is just going to be a little bit beyond that, just about there. So there's 62. Okay, what's the next card? Shout out if you think it's going to be higher or lower than 62. Let's reveal it. And it's lower, it's 37. Okay, point on the number line to where you think 37 is going to be. Well, 37, it's going to be between 30 and 40. And because it's got 7 ones, it's going to be closer to 40 than it is to 30. Just over halfway between 30 and 40, which is there. Okay, what's the next card going to be? Is it going to be higher or lower than 37? Shout out. Let's see what it is. It's 93. It's higher. So, point on the number line to where you think 93 is going to go. Okay, 93, it's more than 90, so it's going to go just about there. Okay, our next number, shout out, is it going to be higher or lower than 93? Let's see, it's lower, it's 14. Where on our number line is 14 going to go? Point to the screen. Okay, so we know it's going to be between 10 and 20. Just before halfway, because it's just a little bit less than 15, one less than 15, so it's going to go just about there. Now our final number, is that going to be higher or lower than 14? Shout out. Let's see, it is higher, it's 50. And 50, well, it's nice to have a tens number here, and we know that 50 is exactly halfway between 0 and 100, so it's going to go just there. Well done for playing Play Your Cards Right. Well then, now that your maths brains are well and truly warmed up, let's get ready for our lesson. And here's our friend Suki to tell us all of the things that we need for today's session. So for this session, you will need the sticks and stones that you got together in the previous sessions, your place value mat, which you've made before, and you will need a pencil and paper or a whiteboard and a pen. Pause the video here whilst you get all of those things together. In the last few sessions, we've been looking at place value. That is what each digit represents in a 2-digit number. A 2-digit number is a number which has got tens and ones. So in the number 42, 42 has got 4 tens and 2 ones. And the 2 ones is worth 2, and the 4 tens is worth 40. In this session, we are going to build on our place value knowledge to solve some mysterious missing number problems. So here's our friend Poppy, and she's asking, what is the missing number? And our number sentence is 50 add something. You can see our detective dog is trying to work out what the something is. 50 add something equals 54. Well, let's fill in the information that we know first of all. So we know that altogether our whole number is 54. And we know that one of our parts is 50. I can also show this with my base 10, with my sticks and my stones. So I've got 5 tens, which makes 50. And we know that all together, our number makes 54. How many ones do we need to go with our tens to make 54? Well, we need 1, 2, 3, 4. That makes 54. So I can fill in my 4 here on my part whole, and then I can fill in my missing number. 50 add 4 equals 54. I can also show this another way round. I could say that 54 equals 50 add 4. Both those two calculations show the same thing. We've just moved around where our equal sign is, but they both mean the same thing. Okay, here's our next question, and Poppy is asking, what is the missing number? So we can see our detective dog there is trying to work out what that number is. Something add 6 makes 36. So let's fill in what we know. We know that our whole number is 36, and I can see that we've got 6 ones there, so I can fill that in, and I can also fill that in on my place value mat. I've got 1, 2, 3, 4, 5, 6 ones. So our whole number is 36. How many tens do we need to go with that to make 36? So we've got 6 ones, and we would need 10, 20, 33 tens. So I can fill that information in on my part whole, and then I can fill it in my calculation. Okay, 30 add 6 makes 36. And again, I can show it this way round. 36 equals 30 add 6. Okay, here is our final question. And again, we've got the detective dog who's trying to work out what the missing number is. Let's see what we know. Well, it says our whole number is 40. And 40 add something makes 40. So we've got our tens number, that is 40. Let's see what this looks like on our place value mat. So I can put my 4 tens in there. And actually, do I need any ones here? I don't need any ones, so I can fill in 0 here, because 40 plus 0 makes 40. And I can fill it in my calculation. I've made a mistake there. Let me just rub that out. 40 add 0 equals 40. I could show it the other way around. 40 equals 40 add 0. Okay, now it's your turn. For each calculation, there will be a missing number. Use your part whole diagram and your place value mat to fill in what you know, and then use that information to work out the missing number. Okay, here's Poppy with our missing number questions. So pause the video here, have a go at the questions using your place value mat and your part whole diagram to help. Then come back once you've done them all. Okay, how did you get on then? Well, let's go through the answers together. So number 1, 30, that's our tens. We're not sure how many ones there are, but our total is 37. So to make that work, we would need 7 ones. Okay. And the next one, we've got 72. Oh, look, there's the equal sign. 72 equals something, add 2. So we know our whole number is 72. We know how many ones there are. How many tens do we need? Well, we would need 7 tens, which is 70. Okay, then the next one is something equals 40 add 8. So we know how many tens we've got. We've got 40 there. 4 tens makes 40. And we've got 8 ones. Well, our total here, our whole number, is going to be 4 tens and 8 ones, which is 48. On to the next one, and we've got, oh, this is a tricky one, something add something equals 63. Well, we don't know our tens or our ones, we just know our whole. But actually, 63 is 6 tens, which is 60, add 3 ones. So 60 add 3 equals 63. Okay, and our last one, it says 40 add something makes something. So we know how many tens we've got. We don't know how many ones, and we don't know the total. Actually, for this one, we can put in lots of different answers. Because if I put in 40 add 5, that makes 45. But I could have put in 40 add 7 makes 47, or 40 add 0 equals 40. So you could have had lots of different answers for that one. Well then, now that you are getting better and better at understanding the place value of numbers, let's see if you can try and solve these next problems without using your place value mat. In these next problems, you have got to fill in the mysterious missing numbers by saying the number of tens and the number of ones in each number. Okay, here is Wilf, and he's asking, what is the value of each digit? So you know your whole number here, you have to say how many tens and how many ones. Pause the video whilst you try and work out the answers, then come back once you've done them. Okay, how did they get on? Well, let's reveal the answers. So here we go. So 12 is 1 10 and 2 ones. 27 is 2 tens and 7 ones. 31 is 3 tens and 1 ones. 50 is 5 tens, but there are no ones, 0. 63 is 6 tens and 3 ones, and 78 is 7 tens and 8 ones. Well done with those ones. Now then, let's move on by using our understanding of place value to solve some problems. Okay, Suki has got the first question, and she is asking, what is the largest 2-digit number you can make? And we've got 3-digit cards here that we can use. We've got an 8, a 3 and a 5. So have a go at working that one out, and then have a go at Wilf's question, what is the smallest 2-digit number you can make? So pause the video here, come back once you've had a go. Okay, how did you get on then? Well, let's start with Suki's question. What is the largest 2-digit number you could make? Well, to have the largest 2-digit number, you'd need to start by thinking, how can I make the largest number of tens? And that would need to be our 8 card. And then, as we've used 8, we've got a 3 and a 5 left. And to make the largest 2-digit number, well, we'd have to use the 5. So our largest number that we can make is 85. Then Wilf's question, what is the smallest 2-digit number? Well, we would need again to start with the smallest number of tens, and that would be 3. And then, as we've used 3, we've got an 8 and a 5, yes, left. And to make the smallest 2-digit number, we would then need to use our 5. So 35 is the smallest 2-digit number. Now I wonder if you could have another little think as an extra challenge and see if you can work out what is the largest even 2-digit number that you could make. Now if we want to make the largest 2-digit even number, well, an even number has to end in 0, 2, 4, 6 or 8. So as 3 and 5 are odd, it will have to end in an 8. So we've used our 8, so to make the largest even 2-digit number, it's got to end in 8, and then that leaves 3 and 5. 5 is the largest card we've got left, so 58 would be the largest even 2-digit number that you could make. Well, that is the end of this session. And today we've been building on our place value knowledge to really understand the value of each digit in a number with tens and ones, a two-digit number. Next time, we're going to look at different ways that we can partition or split up two-digit numbers. So I'll see you next time. Goodbye.